Hello and welcome to this discussion on current affairs. And now it's almost sure that we are having our in a preliminary exam on 4th, and there is no doubt regarding the date of the exam as far as today is concerned, because even IIT, JEE and all, they are talking about conducting the exam at any cost. So civil service exam will definitely be there. So you have to be extra cautious, and you should not be thinking about exam getting postponed or anything. And if at all it happens, let it happen at that time. But right now, your focus should be to prepare with full vigor. Even now, there is time, more than 30 days, almost 35 days time is there. So let us use this time properly and make sure that we are getting through this exam, because of the uncertainties and problem. Some people may not be even appearing. So you have an opportunity to appear and get through this exam in this attempt itself. So take this seriously, and please practice. My formula for success is still the same. Keep revising. You don't try to add too many new things. I mean, except maybe some current affairs, but otherwise everything else you revise. Please practice as many questions as possible. 2 to 3 hours of question practice should be there. Previous questions, previous year questions. You can even look into whatever tests you have conducted already, you have taken already, NCRT tests, everything, whatever tests you have taken till now, everything you please revise, because these are good questions. You might have gone through those, whichever institute, wherever you got, whatever material you got, whatever tests you took, you please revise all those things very seriously and try to take as many tests as possible. We are also coming up with a full test now. Take it with full seriousness, and you can easily get through this exam. Okay. So that is the in general. So let me start today. I'll be focusing more on more on say geography and science related topics, so that some of them are very important and you can expect questions in this area. That is what we are focusing right now. Okay. So first of all, from the geography point of view, there is one topic: Atlantic Meridional Overturning Circulation. Atlantic Meridional Overturning Circulation. So here we are talking about, just a second. Just one minute. Yeah. So and here we are talking about in Atlantic Ocean. We are talking about the circulation, the water circulation in the Atlantic Ocean. So we are talking about Atlantic Ocean. And the topic is, the context is the last 15 years, Atlantic, that circulation, the water circulation, the hot water and the cold water which is there, is weakening. The Atlantic circulation is weakening in the last 15 years. And this is, it can have, it is having dramatic consequences for Europe and other parts of the Atlantic rim countries. Okay. So when you look at the Atlantic Ocean, and we are talking about the Northern Atlantic region, you can see this. And the northern part, we have this side, there is a Europe, and other parts, there can be serious consequences. So warming up of the Indian, and why this circulation. So what is the circulation we are talking about? So let us understand this first. See, what is happening is, we have the North Atlantic circulation. We have a north equatorial current. Then this north equatorial current takes a turn in the northward because of the Coriolis force, and after reaching somewhere in the Atlantic coast, sorry, the US coast, so along the Gulf Stream, then it takes a turn and become North Atlantic drift. This is a warm water which is circulating, and which is still it will continue even along the those Nordic countries, Scandinavian countries. It even reaches the Arctic Ocean. So this is the warm water, and a portion of that warm water, definitely a portion of it takes a turn and that is where the Canaries current, the cold Canaries current, and we have this the central gyre, we can say this is where this Sargasso Sea. Now, what is happening is, along with that, by the time this circulation, we are talking about Atlantic meridional, the topic which are talking is meridional overturning circulation. That means a portion of this, and now we have some cold current. Now you see the cold currents coming, the cold Labrador current, East Greenland current, and also a portion of this sink back, and in the bottom of the ocean there could be some circulation back to the south. Now, this circulation, this kind of a going back, you can see this. So, in the bottom of the ocean, so after reaching around south of Iceland, okay, around south of Iceland, a portion of it turns back and it sinks below. It becomes, there is a warm water reaching after by the time it reaches the northern region, the warm water will come back, it lose its temperature. When it becomes cold, the water will, evaporation also will take place, the salinity also will increase. Two things happen here after reaching here. One is salinity increases, and also, because of the, coldness, I mean, because the warm water will become comparatively cold, and because of the cold conditions, the density increases. Because the salinity density increases, even because of temperature the density increases, and this water will sink, and this is overturning. This is called along the meridian. Okay, what is meridional in Atlantic? Along the longitude, meridional, it will overturning circulation. I mean, it will overturn, and in the bottom it comes back. So, this is called AMOC, Atlantic Meridional Overturning Circulation. Okay. So, I hope you understood what is that. In the surface, we have warm water moving towards the polar region, and but south of Greenland and Iceland, and also the Labrador current and the East Greenland current, which is a cold current, which is in the bottom of the ocean, and also some of the warm water will sink down. It will sink, and because of the sinking, enough water will be there in the bottom. And why is it sinking? Because the salinity is increasing because of evaporation, and temperature is decreasing because of this polar region. So, because of that, the density of the water increases, and this water will start sinking down, and there will be a reverse circulation or other reverse movement of water through the bottom of the ocean. So, this is what we are talking about, Atlantic meridional overturning circulation. Now, what is the problem with that? So, it is in the last 15 years, that is what I am saying, the last 15 years, this overturning part, this portion here, where this overturning is taking place, that is weakening. There is a weakening of the, Atlantic meridional, overturning circulation, and it is having consequence in the climate of Europe and other parts of the Atlantic Ocean. And also, why this is happening? One of the reasons which they are saying is warming of the Indian Ocean. The warming of the Indian Ocean is said to be a key driver behind this. Okay, when the Indian Ocean region is getting warmed up, so what is happening? And this region has additional precipitation. There is additional precipitation. Warming of the Indian Ocean generates additional precipitation, and it also draws, air with warming, it draws air from even Atlantic Ocean into Indian Ocean region. So, the higher level of precipitation in the Indian Ocean reduces the precipitation in Atlantic, and in the process, when in the tropical region itself, in this region, that means near equator, if the rainfall is reducing, so initially this warm waters, the salinity is supposed to be less, but the salinity is increasing right from the beginning. And also, what is happening? So, here now, because of the climate change, what is happening at the equatorial region? So, please listen carefully. Because of the climate change at the equatorial region, the less rainfall. Why? Because the air is attracted to Indian Ocean because extra warming in the Indian Ocean region. So, less rainfall means the salinity increases here. and also near the polar region, near the European region and the where the sinking is supposed to be taking place, in that region the temperature, because the warming, that region has more rainfall. So, here more rainfall, please understand carefully, here more rainfall and equatorial region less rainfall. When the polar region or rather that middle latitude where the sinking is supposed to take place, where the rainfall increases, so the density of the water reduces. So, more rain, less dense. So, the sinking process is not happening properly. So, please understand, see ideally what is supposed to be there, ideally more rain near the equator, the water should be less dense, travel toward the north, the middle latitude region, because of more evaporation and because of cold conditions, the water should sink. But unfortunately what is happening right now, the rainfall in the equatorial region is less, that has been shifted to Indian Ocean region, and near the middle latitude where the rainfall should have been comparatively less because of the warming, the global warming and things like that, here the temperature is more rainfall is taking place. So, the water in this region is less dense, more rain, less density of water. So, because of less density, that water is not sinking down into the bottom of the ocean. So, this is affecting the Atlantic meridional overturning circulation. So, this is the problem, and this Atlantic meridional overturning circulation or AMOC is a large system of ocean current. So, please understand, it is carrying, and in the bottom, the whole thing is traveling toward the south. So, you can see that it is traveling toward the south. So, it is carrying water from the tropics toward the northward in the North Atlantic, and in the bottom of the ocean, it is supposed to come back, or rather it is all along the meridian, all along the longitude, it is going to the south. So, this helps in the heat circulation, not only in the atmosphere, but also even in the ocean. So, it helps in the heat circulation, and it is a very important activity, and if the circulation is getting weakening of it because of the global warming and the change in the climatic condition, it is a matter of concern. That is what we are talking about. So, this is the process I already mentioned. So, on the surface, warm water, I am repeating it, on the surface warm water would have been traveling towards the polar region. So, if I show like this, warm water should have been flowing toward the polar region, and to the bottom of the ocean, along the bottom of the ocean, it should have been the reversal of the flow toward the south in the bottom of the ocean. I do not know how far you are able to make out what I have drawn. So, that is the meaning of it, and because of the global warming, the problem is the global process, otherwise the ocean water would have been continually mixed, and the heat and the energy are distributed around the earth. But this is not happening, or rather it is getting affected in the Atlantic, but in the Pacific Ocean, according to experts, in the Pacific Ocean, this the warm water and the warm water is circulating in both directions almost equally. So, there the meridional circulation is slightly different. Okay. So, this is an exclusive Atlantic circulation, it is an Atlantic circulation issue, and that is where maximum it is affecting. In the Pacific Ocean, the equatorial heat is transferred to both north and south, both north pole as well as towards south pole equally. So, the situation is different, but in Atlantic it is more to the north pole only, very less to the south pole. So, that is why the difference is there. So, ultimately the reason what we are saying is, it is because of the global warming and increasing precipitation in the northern hemisphere, or increasing precipitation near the increasing precipitation just south of, or rather around the middle latitudes near the polar region, it is reducing the density of the water. So, less water goes down, and also the global warming is helping in the melting of ice. The melting of ice is also taking place. So, when the ice melts, as well as when the density and when more precipitation is there, the density of the water in this region is not increasing, it is decreasing. When there is less density of water here, water is not sinking down. So, that is what the issue, and that is what the Atlantic Meridional when overturning circulation what we are talking right now. Okay. So, Atlantic Meridional overturning circulation is affected because of global warming, and this overturning is going back along the meridian, along the longitude in the bottom of the ocean. That is what we are talking in this. So, I hope you understood this. It is a very important concept. The question can be expected from this. Okay. So, that is about Atlantic Meridional overturning circulation. Okay. Now, let me move into another topic. Let me just remove all these things. So, that now this is about this is about red snow. I am sure you might have heard about this. Recently, snow around Ukraine's Vernadsky research base in Antarctica. Ukraine has a research station called Vernadsky research base in Antarctica, in the northernmost Antarctica's northernmost peninsula, has that snow becoming reddish in color. Snow becomes reddish in color, and the phenomena is due to an algae. Okay. So, in this region in Antarctica, this phenomena is because of an algae, and this algae is known as Chlamydomonas then nivalis. Chlamydomonas nivalis, and it this algae thrives in freezing weather. This red pigmented algae is the it is because of the warming and melting. Now, the reason why this is surviving, this algae is surviving in, and why is it becoming reddish? It is again related to warming and melting of ice. Okay, warming and melting. This Chlamydomonas nivalis is the most common type of snow algae found in the mountains across the world. This is found across the world. It is the most common type of algae, found across the world. Greek philosopher Aristotle, he talked about this. Aristotle believed to be one of the first to give a written account of this watermelon snow. It is also known as red snow or watermelon snow. It is also known as watermelon snow or red snow. Almost 2000 years before Aristotle explained this. So, why is it turning red? This algae is actually a member of the green algae family. It won't turn red until the weather warms up. When the weather warms up, when there is warming up of the atmosphere or the weather, the cells, the carotenoids, the cell has carotenoids, the same pigment that gives pumpkins and carrots their orange color. Okay, this carotenoids absorb heat and protect the algae from ultraviolet rays. So, when the temperature increases, the the algae cells has carotenoids, and this carotenoids absorb heat and protect the algae from ultraviolet light, rays. So, the cell has carotenoids and it absorbs heat and protect the algae from ultraviolet light, and it is almost like a sunscreen. So, more sunlight the algae receives, the more it produces this watermelon red. The more sunlight, more warming, more sunlight, the more sunlight it receives, the algae receives, the more it produces the watermelon red pigment which causes snow to melt faster. So, it when the when this is it absorbs heat and it reduces the albedo. Please do not forget, the albedo reduces. Albedo is the reflection of the light from the snow. Albedo is almost 90% over snow, but here what is happening? The albedo it reduces because it is absorbing heat. So, the reflection will reduce. So, the algae produces this tinted sunscreen to keep themselves warm, but because snow becomes darker from the tinge, it absorbs more heat, as a result of which it melts faster. So, it is heat absorption increases. So, it further adds to the global warming in the process, it further adds to the global warming. So, that is what is happening. So, this is because of a particular algae were called Chlamydomonas nivalis. Okay. Now, similarly, in pink snow in Italian Alps, we have seen in July 2020, another, this was in Antarctica in the Ukrainian research station. Now, we are talking about pink snow in Italian Alps, pink snow in Italian Alps. Again, this is again because of the glacier turning pink, because of the same, the algae makes the snow melt faster. Here, these algae are known as cryophylic. Cryophylic meaning which thrives in colder temperature and they can create watermelon snow again. Here, the algae is slightly different. It is called Ancylonema. The algae is known as Ancylonema nordenskio LD. Nordenskio LD. Ancylonema nordenskio LD is found in Greenland, especially in Greenland's dark zones, the so called dark zones in Greenland. And where the ice is also melting, and in Switzerland, and it is same Ancylonema nordenskio LD has turned the ice purple, or so this is same thing in Greenland also, in Italian Alps also, and this is Ancylonema nordenskio LD. This is another algae which makes it reddish, or that pumpkin color, or other whatever the color which we are talking about. So, it can turn it pinkish, or watermelon, not pumpkin, and watermelon color, watermelon snow. Okay. So, this is happening because of the global warming, and as I was mentioning in this also, it is very clear, this Chlamydomonas nivalis. Okay. See, it is actually absorbing the heat energy, and it is one of the most common type of algae found across the globe. And the other one I already said, that is Ancylonema. Okay. So, both it has been extensively found this year. So, that is why this snow is changing its color, because of an algae, and it is the reason is global warming. And when this algae is there, it can absorb more heat energy, it reduces, please remember, the reflection of the light. So, albedo is reduced and further absorption of the heat energy. So, it is a I will say it is a cascading effect. The cascading effect is taking place because of this. Okay. So, that is about the snow turning reddish or pinkish color. Okay. Now, coming to another topic, the ozone layer hole over Arctic recently got closed. I mean that is a good news. Ozone layer hole in the Arctic region. So, the hole which is, see, we always hear about the ozone layer hole in the Antarctic region. So, here we are talking about the ozone layer hole in the Arctic region. It got closed, or rather, according to the European Union's Copernicus Atmosphere Monitoring Service CAMS. Copernicus Atmosphere Monitoring Service. Copernicus Atmosphere Monitoring Service announced that a hole in the Arctic ozone layer, believed to be the biggest reported till now, more than 3 times the size of Greenland, more than 3 times the size of Greenland, it has got closed. That is a good news, but please remember, some people are talking about it might be because of less pollution after the corona pandemic closed down and all. It nothing to do with that. It is, and this is mainly because of the polar vortex. Okay, the main reason is because of the phenomena called polar vortex. The hole in the North Pole ozone layer, which is first detected in February 2020. In February, normally in the spring season it comes out. February 2020 had since reached a maximum. Almost the size became almost 1 million square kilometer size it reached, and European Space Agency scientists and found that it is almost 3 times the size of Greenland. I already said that it has finally, once the summer approached and this Arctic polar vortex got broken down, the Arctic polar vortex broke down and allowed the tropical air to enter into the polar region, allowed tropical air to enter into polar region, and it mixed up, it got mixed with the air, got mixed with the polar air, and ultimately, and this will. So please remember, when there is a weak when there is a weak polar vortex, when the polar vortex gets weakened, that is the time when the ozone hole will get closed. The hole has been, if the polar vortex is strong, the hole may be big. Okay. So, this has happened because of the weakening of the polar vortex. Finally, when the vortex got weakening, then this the intensity reduced and the air got mixed, and more air having more ozone when ozone molecules reach the northern hemisphere, and then finally. So, now what is happening here is, please try to understand. So, this is the suppose equator, this is the North Pole, and try to understand this. And the polar region, please understand, polar region is very cold. Okay, polar region is very cold on ground. So, it is because of extreme cold conditions. See, in the equatorial region, air will rise up. Why? Because of the heating, the air rises up and a low pressure is created along the equator. We have seen that, we know it very well. Similarly, in the in the polar region, a high pressure is created. A high pressure is created near the North Pole, and air will subside, air will sink. So, a high pressure is, so on the top, in the top of the North Pole region, the polar region, especially during the winter season, a low pressure is created on the top, because air from the top region has gone down to the to the ground level, or rather it has sink down. Similarly, in the summer season, the way the air will rise up and a high pressure is created on the top and a low pressure is created on the ground, the same way a low pressure is created on the top. And this low pressure region, okay, please understand, this this low pressure region is what we are talking about, the vortex. So, a polar vortex is an upper level low pressure area. Okay, a polar vortex. What is a polar vortex? Polar vortex is an upper level. It is not on the ground, it is an upper level upper level low pressure area, low pressure area lying in on both the poles. So, now this low pressure area in the upper level is surrounded by our jet streams. So, now let me just add that also, this is surrounded by our jet streams. So, this may confuse you a bit. So, let me just draw it properly. So, here this east moving jet streams on top of it, okay. The jet streams are surrounding it. So, because of the strong, if there is a strong jet stream, this low pressure area, and please understand this low pressure area will be maintained, because surrounding the jet streams are flowing at a very high speed on the top. So, there is no possibility of air mixing into it. And during the winter season, now we are talking about the winter season, please try to understand very carefully. During the winter season, it is full dark. There is no solar energy coming, no light coming, and no ultraviolet rays coming. So, please remember, this is a time when the the polar region no light, and this is a time when no ozone created and no destruction, no creation, no destruction. But when when the winter season is over and when the spring season begins, slowly the light rays will start coming, and the ozone depleting substances, ODS, especially the chlorine atom will become very active. It will start consuming the ozone, and a hole is created during the spring season. I hope you know this fact. I mean, it's a standard fact which we study regularly, and I have taught many times in the class about how ozone hole is created during the early spring season. I have talked about that. Okay. So, anyway, so this when the jet streams are strong and the vortex. Now, in this what is happening, because of the movement, the jet streams are moving from west to east. So, because of that reason, this vortex also will be circulating in a, and moreover this is anti-clockwise direction. Please remember, it is a low pressure, and we know the formula for low pressure because of the Coriolis force ANC. I talked about this many times in the class. See, in northern hemisphere, what is that? Cyclone, the low pressure is a cyclone. Cyclone in northern hemisphere is anti-clockwise in direction. Cyclone in northern hemisphere is anti-clockwise in direction. So, this vortex is circulating in the anti-clockwise direction, in the opposite direction of the clock movement. We know it very well. It is anti-clockwise direction, the same formula. So, in the northern hemisphere, and similarly in the southern hemisphere, when this vortex is created, what will happen? So, here also the the jet streams are moving from west to east. Please see, jet streams are moving from west to east. So, when it is circulating like this, so then here the jet streams are moving like this. Let me draw it properly, otherwise you will confuse, and then you will say, sir, confuses us. So, I am not going to confuse you, please do not worry, and let me draw it properly and just see now. Okay. So, high pressure and jet stream surrounding it, and I said jet streams are traveling from west to east. Okay, west to east. So, in the southern hemisphere, the vortex is in the clockwise direction, and otherwise also we know it. Any low pressure in southern hemisphere is clockwise. So, same thing. So, you can easily draw it. So, what is a vortex? A polar vortex is an upper level low pressure area near the poles, and it is surrounded by the jet stream, and that is why jet streams are upper tropospheric. Please remember, troposphere, then stratosphere. What are jet streams? Jet streams, I am just getting into the whole of geography now. Jet streams are upper tropospheric, narrow, meandering, fast moving wind like a jet of water from west to east. All those things, you please remember that. I mean, it's already there. So, this when these air in the low pressure region in the middle, when there is no mixing of the air from outside because of the jet stream from surrounding, it will continue, and there is no if there is no fresh air entering there. So, when the jet streams are strong, the vortex is equally strong, and when the vortex get weakened, what will happen? There will be breakage. So, this through the breakage will be there, and the air from surrounding will enter into this low pressure region. When the air enters, and this air, the new air which is coming from the surrounding region, comparatively tropical region, when it is coming, it has more ozone, and the ozone layer is closed. That is how it has been done. So, when the polar vortex, what is the bottom line you should remember? When the polar vortex is very strong, the ozone hole can be big. Okay. So, for your understanding, those Aam Aadmi could not understand anything, please remember. Okay. When the polar vortex is very strong, no mixing up of air from the surrounding region, and the hole, the ozone hole can be big. The ozone hole can be quite big. Okay. So, that is what has happened this year. This vortex was quite strong. Ozone hole continued to be very big, and it 3 times the size of Greenland it became. And normally in the northern hemisphere, again this polar vortex may not be that strong for longer time, because of the mixing up between even land and ocean there. The Atlantic, what you call Arctic Ocean surrounded by land. So, when there is land and water intermittently found, warming and cooling, lot of issues are involved, and normally the vortex may not be that strong for longer time. But this year it is unusually strong, and that is why the vortex was big and the hole was also big. Okay. So, that is the concept. So, about the polar vortex, a couple of points, let me just remind you. First of all, I said, where is the vortex? Vortex is an upper atmospheric. Aam Aadmi, please remember, polar vortex is an upper atmospheric low pressure region. Why low pressure? Because on ground it is high pressure. When it is ground high pressure, air will sink, and when air sinks, upper level it will be low pressure. So, very simple logic. Okay. So, ground is high pressure, so upper level is low pressure, and during winter the polar vortex at the north pole expands. So, quite naturally, so winter season, when the winter season comes, what will happen? Otherwise, the sun's rays are there, and the summer season it may be a narrow region. This polar vortex expands, and a larger area will be covered. The larger area will be covered, and this happens fairly regularly, and is often associated with the outbreaks of the cold temperature. And when it expands during the winter season, when it expands, what will happen? This polar vortex, if it is expanded, so naturally more cooler conditions in the northern in northern Canada, and even it can reach up to the US border. Last year, I think there was an expansion of the polar vortex in the upper atmosphere, and that resulted in that very cold conditions during the winter season in north US, in New York and Washington DC and all, were in the grip of Chicago, and all these cities were in the grip of a very cold, very intense and strong cold wave. But when the polar vortex in the Arctic is typically weak, okay, when it is weak due to the presence of the nearby land and as well as mountain ranges, then disturb the weather more so, and then what will happen? It will break, and when the polar vortex is getting weak, it will break, and this cold air will spread to the other to the south. It spread to the south, and the breaking of the part of the vortex is what defines as the polar vortex event. So, when the vortex, or rather when the jet streams become weak, if it becomes weak, what will happen? And it will break off, and some of the cold air in the northern in upper atmosphere will move toward the south, and this is called polar vortex event. Polar vortex event. So, what you should remember is, this polar vortex event will take place when cold air from the upper atmosphere reaches further down to the southern region. When it reaches to the far away from the polar region, it breaks away and reaches, and that is when the cold wave condition. So, initially, now I am repeating once again, initially the the vortex will expand, the size will increase during the winter season in the polar region. Then when the the jet streams get weakened, a portion of this air, this cold air will travel further southward, because it could break away from that vortex and it can travel, and it can be which is called polar vortex event, and this actually occurs when vortex is weaker and not stronger. So, there could be a confusion for option. So, the polar vortex event will take place when the polar vortex is weaker, when the vortex is weaker and not stronger. So, please remember, it will spread out only when the vortex is weaker. Normally, when the vortex is strong and healthy, it helps to keep a current. So, the jet streams will ensure that this cold air is not breaking away, and it is maintaining within that a circular path, and a circular place is located, or rather it is like a disc, and it will be maintained, it will be protected within the jet streams. But when it becomes weak, it will break out and go to the the southern region, or it will move away from the polar region. So, each polar vortex, okay. So, that means in southern hemisphere as well as in the northern hemisphere, it is a persistent large scale low pressure zone. So, low pressure in the upper atmosphere and a high pressure on the ground, less than 1000. So, it may be up to around 1000 kilometers diameter. It is up to 1000 kilometers diameter, and please remember, as I told you, it is in the northern hemisphere. It is very easy for you to understand. The counter clockwise direction, ANC. Cyclone is the upper atmosphere cyclone, in northern hemisphere is anti-clockwise in direction, and in southern hemisphere the opposite, is clockwise in direction. So, in southern hemisphere, the polar vortex will be in clockwise in direction. Polar vortex clockwise in direction. Polar vortex will be clockwise in direction. Okay. So, because it is revolving from east to west. Okay. Both polar vortex rotate from eastward in the polar region, because in the direction of the jet stream, because jet streams are traveling from west to east in both northern hemisphere as well as in the southern hemisphere. So, please do not forget all these things. And now, a couple of points about ozone depletion, let me just remind you. See, ozone hole is not a hole, not really a hole. It refers to a region in the stratosphere, upper stratosphere, where the concentration of ozone becomes extremely low in certain months. So, what is ozone hole? Now, coming to ozone hole. It is a region in the stratosphere, because 30 to 50 kilometer height, 30 to 50 kilometers high in the stratosphere, where the concentration of ozone becomes extremely low. Concentration becomes extremely low in certain months. And why is it getting depleted? Because of ozone depleting substances, ODS. These are chemicals that destroy the Earth's protective ozone layer, and some of the ozone depleting substances, please do not forget ODS. Number 1, the chlorofluorocarbons, CFCs, chlorofluorocarbons, then halogens. Halogens are maybe a group of organohalogen compound containing bromine and fluorine as one or two carbons. So, halogens have either fluorine or bromine along with chlorine, of course. Okay. Then carbon tetrachloride, number 3, CCl4, carbon tetrachloride, CCl4, then methyl chloroform, methyl chloroform, then hydrobromofluorocarbon, HBFC, hydrobromofluorocarbon, not a, then hydrochlorofluorocarbon, I have already said chlorofluorocarbon is there, then HCFCs, hydrochlorofluorocarbon, hydro bromofluorocarbon, then methyl bromide, CH3Br. What is methyl bromide? That is CH3Br. And bromochloromethane. Bromochloromethane. So, this CFCs and HCFCs are refrigerators and air conditioners. So, chlorofluorocarbon, we know where is it used? Air conditioners. And a substitute of chlorofluorocarbon is HCFC, again air conditioner, refrigerator, okay, refrigerators. Then and this HCFCs and halons in fire extinguishers. These halons are used in fire extinguishers. Fire extinguishers. Also, CFCs and HCFCs in form. Then HCF also aerosol propellants. So, they are also the CFCs and HCFCs are also used in form aerosol propellants. Then methyl bromide in fumigation of soil. Methyl bromide in fumigation of soil. Then this is how some of these uses are there. Okay. So, 8 ozone depleting substances, please do not forget CFC, halogens are fluorine and bromine involved in it along with chlorine, carbon tetrachloride CCl4, methyl chloroform, hydrochlorofluorocarbon, methyl bromide, which is used in fumigation of soil and all. Then this what do you call methyl bromide, CH3Br, methyl bromide, and also bromochloromethane. So, these are some of the ozone depleting substances which we are using and we are phasing out also. And please do not forget the Montreal Protocol, and it is quite effective. 1987, things have improved a lot, but still the ozone hole closing is not complete. It may take another 30-40 more years, maybe by 2050-60 we may be able to completely close it, because we are phasing out all the ozone depleting substances from our day to day use. But what we have already used and sent into the atmosphere, it is still reaching, and that is why it is taking some more time. Okay, the chlorine or the chlorine atom which has reached there, especially from the chlorofluorocarbon, it takes 30-40 years to reach the upper layer, because slowly it rises up. So, that is why it is taking time. So, that is about the so this time the news was that the polar vortex, because of the strong polar vortex, almost 3 times the size of the Greenland was the size of the ozone hole created this year, which started appearing in February and finally it was entered in end of April and May. But it was a big one, and this is because of the peculiar strength of the polar vortex. This time the polar vortex is quite strong. If the polar vortex is weak, it will allow the air to come out, and it will allow the air from the other region to enter into this region, and intermixing will happen faster, and the enough ozone will be there, and the ozone layer on the ozone hole is closed in normal circumstances quite faster. This year did not happen. That is why I also talked about polar vortex and the ozone depleting substance. So, both are important from an exam point of view. The direction, movement, everything is very important. Now, coming to another topic which was in news is about the Earth's magnetosphere. Earth's magnetosphere. Recently, the scientists of the Indian Institute of Geomagnetism Indian Institute of Geomagnetism. Okay, have developed a one-dimensional fluid simulation code. One-dimensional fluid simulation code capable of studying a wide spectrum of electric field structures, or it can study the Earth's magnetosphere, and it can be used in planning of future space missions and all. It can be used in the planning of future space missions. So, a one-dimensional fluid simulation code, Indian Institute of Geomagnetism scientists, which can be used in the planning of future space missions and all. It developed in a electric field structure in space plasma. Okay, when they what is in space plasma, they could develop an electric field structure. What is the plasma? Plasma is the matter in the fourth stage or other fourth state of matter. Like we have solid, liquid, gas, and plasma, and so it is using, and in the Indian Institute of Geomagnetism, and this is where these experiments were conducted, and they could find. Now, what is this Earth's magnetosphere? Now, coming to what is the Earth's magnetosphere? Earth's magnetosphere, it is that area of the space around our planet or other around our Earth that is controlled by the planet's magnetic field. Magnetosphere is that area of space, that area of space around a planet that is controlled by planet's magnetic field. The shape of the Earth's magnetosphere is a direct result of being blasted by a solar wind. Our magnetosphere shape is closely linked to the intensity of the solar wind. Okay, so if we look this way, if this is Sun and this is our Earth, and the magnetosphere okay. So, what is happening? The solar wind compresses the sunward side to a distance of only 6 to 10 times the radius of the Earth. So, this is Sun toward, this is the sunward side, the distance may be around 6 to 10 times the radius of Earth. The sunward side, because of the pressure from the solar wind. But on the opposite side, and there is because of the, and there is something called a bow shock, or this we can say so we are talking about a a boundary of this, a boundary of this, what is called bow shock. There is a boundary called bow shock, and also there is a magneto sheath. I'll just come to that. This is a bow shock. Let me see that first. So, the solar wind compresses 6 to 10 times, I said. There is a bow shock. Then there is a, most of the solar wind particles are heated and slowed at the bow shock, and it will turn around. Okay, it will go away. It will turn around along and the Earth, around the Earth, and it is called the magneto sheath. This when the solar wind turns around and moves, it is called the along magneto Sheath. Okay, magnetosheath, and the solar wind drags out the other side, this side almost 1000 times, possibly up to 1000 times the Earth's radius. So, here the magnetosphere may be up to 1000 times the radius of the Earth. So, in the sunward side it is only 6 to 10 times the radius of the Earth, on the other side it is the, and this is called the magnetotail. So, this opposite side is known as the magnetotail. The outer boundary of the Earth's conformed geomagnetic field. Now, where the, so we have a say this one, this is called bow shock, and where that boundary where all these plasma matter comes, and the plasma matter gets realigned and all here, where the realignment, where the aurora or borealis and australis which take place, that realignment is known as the magnetosheath. Okay, the realignment is known as the magnetosheath, and the magnetotail I said. Okay, the sunward side, that the thickness may be only 6 to 10 times the radius of the Earth. Okay, so and this is how the shape will be there. So now we are talking about now what is the discussion here? The discussion is in the Indian Institute of Geomagnetism. The scientists have developed a generalized one-dimensional fluid simulation code which are capable of studying this magnetic field of the Earth and also magnetosphere, and this can be helpful in planning of future space missions. And this I said there is a bow shock, that is where the alignment of the solar wind, the protons or rather the electrons which are coming, the charged particles which are coming, it will be getting aligned, and the Earth's magnetic field is able to support us and help us in preventing these solar wind directly bombarding and hitting our atmosphere, and in the process we are saved, and atmosphere is still there because of the Earth's magnetic field, otherwise this would have been lost long before. Okay. And then in the plasma, which I said in the solar wind, the plasma, the sun is a major source of plasma deposition in space around the Earth, and it is the plasma which is blown from the sun and it is coming toward the Earth is called the solar wind, and the plasma is the most common state of matter in the universe. Plasma, most common state of matter in the universe. I said there are 4 states of matter: solid, liquid, gas. We have studied in school also. Plasma is the most common state of matter in the universe. These are gases of ions or free electrons. The speed of the solar wind can be anywhere between 300 to 1500 kilometers per second. 300 to 1500 kilometers per second. And when it carries its solar magnetic field, called when it is in the outside the Earth's magnetic field, it is called the interplanetary magnetic field, IMF, interplanetary magnetic field, when it is outside the Earth, and the interaction of the interplanetary magnetic field with the Earth's magnetic field, and where it happens, that is the magnetosphere of the Earth. So, the solar wind and this study of the plasma process is very important. That is what the one dimensional study we are talking about. It can help in the understanding how the plasma and the solar wind can affect our satellites and all. The artificial satellites can be affected, and it can help also in improving the space weather model, weathering sorry, the to understand the weather phenomena in the atmosphere, and it helps. I mean, if you have the plasma study or the magnetosphere study. Okay. So, this is what exactly and the scientists are doing, and that is why it was in news. Now, similar to this, there is something called, I mean, the magnetosphere of the earth. The magnetosphere is the sphere of the gravitational force, where the gravitational force of the earth is there. So, when I have already said, one second, what is the the magnetosphere. So, one second, that magnetosphere is that area of space around a planet that is controlled by the planet's magnetic field. Now, when it comes to the southern hemisphere, now there is a peculiar problem in the magnetosphere, that is what is known as the South Atlantic Anomaly. So, it is related to this. So, let me just talk about the South Atlantic Anomaly. See, this means recently a European Space Agency satellite called the Swarm Constellation. Swarm Constellation is a European Union or European Space Agency satellite constellation, and it has it has identified and it has given some updation about the South Atlantic Anomaly. So, what is South Atlantic Anomaly or SAA? South Atlantic Anomaly is the behavior of the Earth's geomagnetic field in the area between Africa and South America. South Atlantic Anomaly is the behavior of Earth's geomagnetic field behavior of the Earth's geomagnetic field in an area between Africa and South America. Okay. So, what are we talking? So, please see, between Africa and South America in South Atlantic Ocean, the Earth's inner in a gravitational line, or rather the height of the gravitational line, it is dipping and it is coming to a depth of, or it is reaching up to 200 kilometers from the surface. Now, this is the region we are talking about where the South Atlantic Anomaly is there. Now, what is happening here is, so let me one second. So, what is happening here is, I talked about the Earth's magnetic field, something like this. The magnetic tail. Now, near this is South America, and between Africa and this magnetic lines, height from the surface of the earth is less than 200 kilometers. In this region, the magnetic line height is less than 200 kilometers, is dipping down up to an altitude of 200 kilometers from the surface of the earth. So, this kind of a dipping of the magnetic lines, or this is also known as the Van Allen radiation belt. Van Allen radiation belt. So, this these magnetic lines are also known as the Van Allen radiation belt, and between Africa and South America in the Atlantic Ocean, this is called South Atlantic Anomaly. the height of the magnetic lines are dipping and the height is only around 200 kilometers. The height is only around 200 kilometers. So, that is an unusual thing, and this that means, you know, the charged particle, the sun's energy or rather the plasma which is coming, the plasma which is coming, it can come up to a height of 200 kilometers above, meaning some of the satellites in this region will be exposed. See, most of the satellites will be within the magnetosphere of the earth, so that the charged particles coming from the sun will not affect these satellites. But in this region, if the satellites are there, any satellite orbiting at that time above the South Atlantic Ocean between Africa and South America, they may get exposed to this plasma or rather the solar wind. It can affect these satellites. The effect can be, it can result in destruction of the satellites also. So, this South Atlantic anomaly is a near earth region, or rather it is a near the earth's surface where earth's magnetic field is weakest. So, what is South Atlantic anomaly? South Atlantic anomaly is a near earth region where earth's magnetic field is where earth's magnetic field is weakest. So, that is between South America and Africa is weakest related to an idealized earth centric dipole field. And normally what we expect, an ideal circular thing is there, it is the weakest here. And this weakening of the magnetic field is still continuing over the last 200 years. According to scientists, over the last 200 years, the magnetic field of our earth has lost almost 9% of the strength on a global average. Okay, I am not talking about this region. In the last 200 years, the magnetic field has lost almost 9% of strength, and this large and rapid shrink has been observed, and a large and rapid shrink was observed above South Atlantic. We do not know what is the reason. Above South Atlantic, the weakening is found all the more prominent, and that is what we have seen. The impact of this, the magnetic shield which is there, it plays a very important role in preventing the plasma from entering the Earth's atmosphere, the radiation, the solar wind. So, it can affect, rather if the magnetic field is weakening, these plasma may enter, it can even result in blowing away our atmosphere. So, magnetic field plays a very crucial role in protecting our atmosphere. So, it can be affected. So, weakening of the Earth's magnetic field may not be a good thing. So, this Van Allen radiation belt, that is the belt or is a zone of energetic charged particles, most of which originate from the solar. So, where the solar wind or rather the plasma gets aligned, that is what we call it as the Van Allen radiation belt, where the solar energy is coming, that is called the Van Allen radiation belt. Okay. So, that is about this particular South Atlantic anomaly. And the Swarm Constellation, I said Swarm Constellation is a European Space Agency mission to study Earth's magnetic field. Okay. So, the Swarm Constellation is an European Space Agency mission to study Earth's magnetic field. Mission to study Earth's magnetic field. And it is European Space Agency's first constellation of satellites for Earth observation. This is for Earth observation. And it is similar to our India's remote sensing satellites. And the Swarm constellation has 3 satellites. Swarm constellation has 3 satellites, and they have named it as Alpha, Bravo and Charlie. Okay, and it is named as, and two different polar orbits. It is around 450 to 530 kilometers altitude. That is not so important. That is an Earth observation satellite. That is a Swarm Constellation. Okay, so that's about it. Now another topic similar to this solar wind and all those things. So let me just remind you this topic. Just a second. Solar minimum. Okay, let me talk about another very interesting similar to this solar wind and solar minimum. Solar minimum. One second. So according to research, the sun is reportedly going in a solar minimum in 2020. In 2020, solar minimum. So the cosmic rays have started intensifying. Now please be careful. So solar minimum and the solar rays, the cosmic wind, cosmic rays have started intensifying. Have started intensifying, and it could be dangerous for astronomers, astronauts, as well as for even satellites for that matter. It can be dangerous for astronauts and all who travel in the space. So the solar minimum is a regular part of the sunspot cycle. So what is solar minimum? It is a regular part of sunspot cycle, and this cycle normally lasts once in every 11 years. And the sun's magnetic field during the solar minimum, the sun's magnetic field becomes weak, allowing extra cosmic rays into the solar system. The sun's magnetic field becomes weak. Sun's magnetic field becomes weak, allowing extra cosmic rays into the solar system. Allowing extra cosmic rays into the solar system. So these cosmic rays are high energy particles. I already told the solar wind, and it can move up to the speed of light also. The cosmic rays are intensifying because the lack of sunspot or the solar flare. So now what is happening is, so it can have a health risk for if more cosmic rays are entering into the atmosphere. So and in the process, but during the solar minimum, the sun's energy, the overall energy released by the sun may be slightly less. Solar minimum, the overall release of heat energy may be less, and it can be acting counter to the global warming, or it can control the global warming effect a bit. But the excess cosmic rays affect our electrochemistry of the Earth's upper atmosphere, and it can even trigger lightning and all. The excess cosmic rays affect the electrochemistry of the Earth's upper atmosphere, upper stratosphere. Earth's upper stratosphere can be affected. It can result in lightning and all those things. So now what is this solar minimum all about a bit more? Let me just solar minimum, solar maximum. Let me just talk about. So during solar minimum, there are minimal sunspots and sun flares. Okay, solar minimum. minimal sunspots and sun flares, minimal, and the opposite is solar maximum. And when the magnetic field grows stronger and the sunspots and flares activity increases before subsiding again. So, during the solar maximum, what is solar maximum? During solar maximum, the magnetic field of the sun grows stronger. Magnetic field of the sun grows stronger. The magnetic field of the sun grows stronger, and the sunspot and sun flares activity also will increase. The sunspot and the sun flare activities increase. Sunspot and sun flare activities will increase, and during this, when the more sunspot and sun flare, if when there is a very strong activity, we must see more aurora activity during the solar maximum, more aurora activity during solar maximum. More aurora activity during solar maximum, and it is related to the amount of charged particles released into the atmosphere. But solar minimum, the solar ultraviolet radiation decreases, okay, during solar minimum. Ultraviolet radiation decreases. Ultraviolet radiation decreases, but the effect of this primarily hits the stratosphere and higher altitude, so it does not make much difference. And also, during solar minimum, the sun's magnetic field gets weakened. So, that is another issue. The solar minimum, sun's magnetic field gets weakened, and it provides less shield from the cosmic ray, the other rays coming from the extragalactical objects and all. It provides less shield. When the sun's magnetic field is weak, the entire solar system will be affected by the more from the supernova explosions and all, or other it will less shield from other cosmic rays. So, because of this, the sun's magnetic field may get weakened and maybe other rays may be coming and all. Now, these sunspots and sun flares during the solar maximum, what are they? Sunspots are areas which appear very dark. So, in the opposite of minimum is solar maximum, and when there is maximum, there can be sunspot and sun flare. I will come to that. Sunspots are dark, comparatively dark, and the cooler part on the sun surface, dark and cooler part on the sun surface. See, now this dark and cooler part on sun surface when solar maximum is there, cooler part on the part of the sun surface. Why? That is the question. Why is it dark and why is it cooler? Because they are cooler compared to the other part of the sun. Why? Because of the very high and the sunspot are relatively cool. That is because the magnetic fields are very strong. During solar maximum, the magnetic field of the sun is very strong. Magnetic field of sun is very strong. because of the very strong magnetic field, they keep some of the heat within the sun without reaching the surface of the sun. Okay, the magnetic field will hold or withhold. It will withhold the heat within the sun. It will withhold the heat within the sun, and because of that, the heat energy will not reach the surface of the sun. So that is why it becomes sunspot. So please remember, solar sunspot cycle is there when solar maximum is there, not when solar minimum is there. It is when there is solar maximum. And what is solar flare then? This magnetic field is very strong. These magnetic field lines near the sunspot often get crisscrossing and get tangled, and it may sometimes reorganize also. So near the sunspot where there is maximum gravitational pull is there, near the sunspot where the magnetic field is very strong, where the magnetic field is very strong, near the sunspot where the magnetic field is very strong, these lines may often tangle, cross and reorganize. The magnetic lines may reorganize or rearrange, and this reorganizing of the magnetic can result in sudden explosion of energy. This can result in, it may reorganize and it may result in sudden explosion of energy. Sudden explosion of energy called solar flare. So suddenly, in a bout, a sudden release of energy from the surface, the solar flare releases a lot of radiation into the space, energy, radiation into space, and this can be in the form of, ions, charged particles, and the solar flares are sometimes accompanied by coronal mass ejection, CME. It is also, solar flares are accompanied by coronal mass ejection. See, corona, what is corona? Corona is the outer atmosphere of the sun, and it is like huge bubbles of radiation from the sun, from the outer atmosphere, from the outer atmosphere of the sun. Corona, please know, coronal mass ejection. Corona is the outer atmosphere of the sun, and when they explode in the space at very high speed, the sun's magnetic field gets reorganized. Okay, so when the magnetic field is very, very strong, please see, and the magnetic lines may get rearranged within, and during that process there can be, so surrounding the sunspot, there can be solar flares, and it can even lead to coronal mass ejection, CME. Corona is the outer atmosphere of the sun, so from there also it will be ejecting and coming out, it will explode, and but solar minimum, no such activity. The sun's magnetic field is weak, no sunspot, no solar flare, and during this time the problem may be, and no auroras, I mean very weak aurora during that time, because aurora australis and aurora borealis, please don't forget, aurora australis and aurora borealis. Borealis in the northern hemisphere, australis in Australia, Australian side, and during the solar maximum, this aurora australis and aurora borealis will be very strong. When a particularly strong coronal mass ejection is taking place, it can also even affect our power grids and all. It can even affect that. It can even destroy the power grid system also in the process. So, but the solar minimum, least activity from the sun, Sun's energy, sun's magnetic field is less, but this is a problem for the because of the cosmic rays. Okay. So, we said the we are talking about solar minimum. Right now, we are talking about solar minimum, and according to researchers going through a solar minimum right now 2020, cosmic rays have started intensifying. Okay. So, cosmic rays will intensify because sun's gravitational force is less, and these cosmic rays from the other interstellar or other planet, other stars also it may be coming, and this can be dangerous for astronauts, cosmic rays and astronauts, and it can create other problems because the cosmic rays. So, it is part of the solar minimum, is part of the it is a cycle, that 11-year sunspot cycle, and the other in extreme of in the sunspot is because of the solar maximum, the other extreme is solar minimum, and during solar minimum we will find more cosmic rays coming, and coming of this cosmic rays to the earth or rather to the outer surface, it can even affect the astronauts and all. That is why 2020. So, but please understand, this kind of a solar minimum is a regular feature. It is nothing new. It is nothing extraordinary. It happens. But there was an extreme solar. There was a minimum on Earth. There was an event. See, when solar minimum, less energy is released into the Earth's atmosphere. No sunspots, no sun flare. But there was an event in 1800s or early the 19th century called, then it was named as Dalton minimum. Let me just talk about that also. It was in news recently, Dalton minimum. See, Dalton minimum occurred in 1816. That is nothing to do with solar minimum and all. Okay, this is a different one. I am just reminding you, since solar minimum was talked about, some people talked about Dalton minimum. Dalton minimum was recorded in 1816, and that was the year when there was no summer on Earth, and temperature dropped, crops failed, many people around the world starved to death or died out of cold also. And what was happening? It has nothing to do with solar activity, sun's activity. All those problems were because of a massive, volcanic eruption in Indonesia, the eruption of Mount Tambora. A massive eruption of Mount Tambora in Indonesia. It resulted in, it threw up so much of dust and clouds and even water vapor into the atmosphere in 1816. Because of the effect of this volcanic eruption, there was no summer. So, that event which happened, and nothing to do with, please remember, nothing to do with the solar minimum. And for many years, scientists talked about this could be, without knowing it, this could be because of some lower sun's activity and it is a solar minimum and all, it was talked. But the truth is, it was only because of an volcanic eruption. So, that is called Dalton minimum, nothing to do with solar minimum. But solar minimum's only problem is cosmic rays impact will be more, because sun's magnetic field has reduced, or rather the intensity of the magnetic field has come down. That can result in more cosmic rays reaching the earth and the astronauts, which can be more dangerous for the lives of the astronauts because of the incoming cosmic rays, and this cosmic rays because of weakening of sun's magnetic field, not Earth's magnetic field, sun's magnetic field. So, that is about the solar minimum and Dalton minimum, right. So, we will have a break, and after the break at 3:30, I will continue my discussion, maybe 1 more hour. I will be discussing various aspects. I have another 8-10 topics to cover. So, I will be doing that. Let us have a small break, otherwise you will also feel bored. So, even I feel bored because I have nobody to stand in front of me, sit in front of me and listen to my class. and you are sitting at your comfort at your home. So, naturally, this is not a very easy thing to do. For teachers also, I am talking to empty chairs and empty seats and only to the camera. So, let us have a small break at 3:30. I will restart and I will be picking up some more topics related to geography, then I will move into some science related topics, and these are all very interesting and very important for the exam perspective. So, let us have the break and I will continue at 3:30. Hello, welcome back in our discussion geography related current affairs. Now, let me talk geography and science, we can say. I am not only talking about geography, a bit of science also. Then there was a very specific name called the Bobble Experiment. I am sure you might have heard about this. Bobble Experiment. This is a team of Indian Institute of Science, Bangalore and UK based researchers. So, for that is Indian Institute of Science plus UK researchers, they have created a blueprint for accurate prediction of monsoon. Their aim is to have accurate prediction of monsoon, tropical cyclones and other weather related forecasts under this Bobble experiment or Bay of Bengal boundary layer experiment. What is this Bobble experiment? This is Bay of Bengal boundary layer experiment. Okay, that is what is known as Bobble Bay of Bengal boundary layer experiment is a project funded by Union Ministry of Earth Science Ministry and the Natural Environment Research Council of UK, Earth Science India and Natural Environment Research Council of UK, and it tries to determine and quantify and even to create a model ocean atmospheric interaction. So, they are trying to determine, quantify and even to create a model of ocean atmosphere interaction in South China, in Southern Indian Ocean or in Indian Ocean, or especially in the South Asian monsoon. So, to create, determine, quantify and create a model of this ocean atmospheric interaction. And the experiment created a blueprint for future weather system observation experiments and everything. So, why this Bobble? The Bay of Bengal plays a very fundamental role in controlling the weather system that makes up the South Asian summer monsoon. Bay of Bengal plays a very crucial role, and the southern Bay of Bengal has cooler sea surface temperature. Please, the southern Bay of Bengal. Now, what is the when we talk about Bay of Bengal, and be very clear, we are talking about this portion. See, we are talking about this region. This is the southern Bay of Bengal we are talking. So, the southern Bay of Bengal has cooler sea surface temperature that influences the ocean atmospheric interaction. This is the South Bay of Bengal, and they have cooler sea surface temperature, cooler SST, okay, cooler sea surface temperature, that is what we are talking. And compared to the southeastern Bay of Bengal, now two things here. So, be careful and what I am saying and try to understand very carefully. Now, we are talking about southeast Bay of Bengal and southwest Bay of Bengal. So, this could be the southeast Bay of Bengal and this could be the southwest Bay of Bengal. So, we are saying the southeastern Bay of Bengal and compared to the southwestern Bay of Bengal is cool. Now, this side is more cool more saline, less rainfall in this region, more saline, and receives much less rainfall. See, Tamil Nadu region and all, much less rain. So, the southwest Bay of Bengal is cooler, more saline and receives much less rainfall. This region has much less rainfall and it is influenced by the summer monsoon current. So, why this is compared warmer? Because the water enters here. Okay, in the southeast Bay of Bengal region, water enters from the Pacific Ocean here through the Malacca Strait and all. Okay, so that is the warm water from the Pacific will be entering into this region, and this region has more rainfall also. So, and this is the southeastern Bay of Bengal is warmer and less saline because more rainfall, so less saline. So, here we can say it is warm, less saline, less salinity and more rainfall compared to the western side. Okay, that is the reason. So, this Bobble experiment is to study this, to examine the impact of these features on the monsoon. This experiment was undertaken. So, how, see, we know the dipole. Dipole mein kya hai? See, in this Indian Ocean dipole, that is a different thing altogether. Okay, Indian Ocean dipole, we say the east is comparatively cooler. Eastern Indian Ocean is cooler than the west. West is warm. East is cooler. That is a different thing altogether. That is about dipole. But here we are talking only about Bay of Bengal. Bay of Bengal's east is comparatively warmer because warm water from the Pacific Ocean enters through our Malacca Strait and all, South China Sea and that side, and also from south also it will be entering. So, the warm water from the Pacific will enter here, and this region has more rainfall. This region of Indonesia, Malaysia region is tropical evergreen forest region, more rainfall, less saline. Okay. So, this is how the difference. So, please do not confuse the Indian Ocean dipole, I will talk separately. So, the Bobble deployed 2 ships, 6 ocean gliders. So, how this experiment is conducted, this deployed, one second. So, it has deployed 2 ships, 6 gliders, 6 ocean gliders, 8 floats to collect an unprecedented range of oceanic and air sea flux. Okay, and 8 floats to collect data. In an collect data in an unprecedented range of data on various observations. So, this is from southwest to southeast Bay of Bengal and the east west and the north south path and the location and everything. So, that is what is done. So, this is called the Bobble experiment. So, that is the between, okay, please see this region. So, Bay of Bengal is exclusively for Bay of Bengal, that is different from the rest of the dipole thing which we talk about. Indian Ocean dipole is different. So, let me just talk about the Indian Ocean dipole a bit. I am sure you might have heard in the monsoon, Indian Ocean dipole. So, the Indian Ocean dipole is also known as the Indian Nino. Like El Nino, Indian Nino is an irregular oscillation of sea surface temperature. Irregular oscillation of sea surface temperature in which the western Indian Ocean becomes warmer, especially in the summer season. Western Indian Ocean warmer comparatively to the eastern Indian Ocean part, which is cooler. Eastern will be cooler. So, western Indian Ocean is warmer. So, if I remove all these things, let us talk about this dipole a bit. Okay, let us see the dipole. So, we are saying that during the, and this is a sea surface, the oscillation, which is talking about irregular oscillation of sea surface temperature. Eastern part is cool and the western part becomes warm. And when it is warm, rising above the air, so there will be the cool air will tend to travel towards the warmer air, and this will result in, this is called a positive phase or positive dipole. Positive dipole. This is what we call it as the positive dipole. And if the east becomes warmer and the west becomes cooler, then it will be the negative dipole. And there can be a neutral one also. If there is no difference, then it may be a neutral one also. So, warmer than average, the western side, if it is warmer than average, that is what we expect, that is what we want. So, during that time, this will result in a good monsoon. This is a good monsoon and a positive dipole. So, this is an irregular sea surface temperature oscillation. Of all the ocean, Indian Ocean is the warmest, please remember, because it has no access to cold Arctic water from the north. Indian Ocean is the warmest of all the ocean because there is no access to the cold ocean water from the Arctic region. The warm Pacific water enters from the east and pushes the warmer Indian water to the west, forcing the cold water to upwell in the east. So, it will be cool. So, when the warm water enters, it will push to the west and upwelling of the cold water takes place here, that is why it becomes cool in the east. So, upwelling of cold water in the, see, when the warm water goes to the west, so naturally accumulation of the water will take place, some water will sink and there will be a reverse flow in the bottom, and upwelling of the cold water, the water from below will rise up and that will result in a cool water in the east. And the temperature in the eastern part normally oscillates between warm and the cold compared to the western part, and that is why the positive, neutral or negative we can say. There can be neutral dipole if there is no difference in the temperature between the west and the east, but if the west is warmer, that is positive dipole, that is when normal monsoon will take place. And when the unusually strong positive dipole in 2020, we have found that an unusually strong positive dipole and higher than average rainfall in the Western Africa and monsoon, etc., and the drought like condition, maybe slight drought like condition in Southeast Asia and Australia. So, when there is a strong dipole, so when there is a strong dipole, that is west is more warmer, more rain in Africa, good monsoon, and a drought like situation in Australia and Southeast Asia. So, the rainfall in Southeast Asia and all will be less. When the Indian Ocean dipole event occurs, the rainfall tends to move along with the warm waters to the west. So, more rainfall in the western side and especially the East African countries and all. And if the eastern Indian Ocean is warm, more rainfall in the east, and the west will be a problem, west there will be less rain and there will be drought like conditions in Africa. So, this plays a very crucial role. So, that is the dipole and the Bobble experiment. Okay. So, do not forget. So, very important for us, and from preliminary point of view and all, questions can be expected. So, be ready. So, and that is about the dipole and Bobble experiment. Now, let us talk about a bit on the Antarctica research, the National Center for Polar and Ocean Research. National Center for Polar and Ocean Research. Okay. This this is the NCPOR, National Center for Polar and Ocean Research, NCPOR, and it is located in Goa, Panjim, and it is established an autonomous research and development institution. It is under the Ministry of Earth Science. It is under the Ministry of Earth Science, and it was established in May 1998. This NCPOR was established in 1998, and it is designed as a nodal organization for coordination and implementation of India's Antarctic program. This National Center for Polar and Ocean Research, it is the implementation of the Indian Antarctic program, including the permanent stations in Antarctica are maintained by NCPOR. Okay. So, Antarctic research, it is the nodal center for Antarctic research. Nodal Center for Antarctic Research, and the scientific mandate is quite complex because it has to do with the entire the polar science and biology, chemistry, everything is involved in it. And we have two stations. See, what is the first station was Dakshin Gangotri, and that has been abandoned, or rather in the nearby we created another station called Maitri in 1989. So, now Dakshin Gangotri is no more in operation. Then we have established another one called Bharati, that was in 2011-12. So, we have two centers, and every year there is an expedition, and we are going to Antarctica since 1980. Every year there is an expedition, right from 1980, and normally the expedition is in the summer season in south, that is December, January is the expedition time. And these days, for many days and many years, we are flagging off, we are starting our expedition from Cape Town in South Africa. We are starting from Cape Town, South Africa, and since the last 4 years, this is undertaken by a Russian cargo vessel called MW Ivan Papanin. So, we are using a Russian cargo vessel Ivan Papanin for the last 4 years. This year also, I mean 2019-20 also, our expedition has gone from Cape Town, and it has a small boat also. Maximum 30 scientific crew members can be accommodated on board. 30 scientific crew members can be accommodated on board, and Maitri since 1988-89, it is located at 70° east. I am talking about Maitri. Maitri 70° south, sorry, not east, 70° south, and 11° east, or almost 12° east. Okay. Maitri is located at 70° south and 12° east approximately, and Bharati okay, Bharati is located around 3000 kilometers away at 69° south and 76°. Okay, in a 76° west. Sorry, it should be east only. So, 69° south and 76° west. Okay. So, anyway, so that is quite far away, that is Bharati. This was about the Maitri we were talking. One second. Okay. So, we have it is located two different places altogether, and India is one among the few countries in the world where we have two research stations. And this year also the expedition has gone from Cape Town. So, these were the highlights, and we also have an Arctic research station in uh, uh, Norway. Okay, and that is in Svalbard Island. Okay, we also have an Arctic research station in Norway, in which is called in the Svalbard Islands. That is uh, I just forgot the name. I mean, please cross check that. Suddenly I remembered. Please remember there is an Arctic research station in Norway, that is in Svalbard Island in Norway, and it has been established I think in 2013. Okay, I think Himadri. I just forgot the name. Please cross check that. You can easily find out. So I am not searching it right now for you. So please ensure that you are looking into that. Okay. So that's about this particular issue. Then now let me come into another set of issues. Uh, then recently you might have heard about the possibility of having a new continent. I don't know whether you have heard of it. It is there in news for quite some time right now. So let me just talk about that. Just 1 second. Let me take that topic. So it is called Zealandia, and some of veterans, you might have already heard about it because it was in news for quite some time. The heading is Zealandia. Okay, Zealandia, the New Zealand. Okay, where New Zealand. Okay, the Zealandia is from New Zealand. Might be, and it's a smaller neighbor of New Zealand, but according to in the American Geological Society or Geological Society of America, Geological Society of America, this Zealandia could be another continent. It could be the 8th continent. We have 7 continents right now. It could be the 8th continent. And scientists say it is a huge landmass, almost entirely submerged in the South Pacific. 94% is submerged, and it is a huge landmass. 94% submerged in the Southwest Pacific, and they are saying that this Zealandia is almost 5 million square kilometers. Zealandia, this new continent which they are suggesting, it is 5 million square kilometers, but 94% are submerged in water, and New Zealand's North Island, South Island, and New Caledonia, and these are some of the bigger islands in that. And but the problem right now is there is no international body in charge of designating official continents. Okay, so there is no international body which is in charge of designating official continents or designating official continents. But why are we calling Zealandia a continent? And that is a question which everybody is asking. Researchers are looking at different sets of criteria, and they are saying if this particular area also satisfies some basic criteria, then we can call. So, 4 points they are insisting, the scientists are insisting should fulfill to call a particular landmass as a continent. So, elevation above the surrounding area. One is elevation above the surrounding area. Number 2, distinctive geology. Distinctive geology, a well defined area. A well defined area. And number 4, a crust thicker than regular ocean floor. A crust thicker than regular ocean floor. So, these are the 4 requirements to have a continent, and Zealandia continental crust has a thickness ranging from anywhere between 10 to 30 kilometers. Normal oceanic crust may be 5 to 7 kilometers thick. So, even though it is below the water, it is a continental crust, and there are some places up to 40 kilometers thick below the islands, some of the South Island and all. So, then so there is a distinct geology, a well defined area, the crust is thicker than the regular ocean floor, and also elevation above the surrounding area, it is elevated above the surrounding area also. That is why all the 4 conditions are fulfilled. And when it comes to a continent, okay, what is a continent? So, but there is no official body to declare a particular this region as a continent right now. The continent was applied, and any area of land of any size not separated by water, including islands, or the continent is applied to, the word continent is applied to any area of land, applied to any area of land of any size, not separated by water, not separated by water, including islands can be termed as a continent. Like Australia was is designated as a continent, even though it can be termed as an island. So, the continent term derived from Latin term terra continens. The Latin term terra continens, and it means land held together or connected land. Okay, continent means land held together or connected land. Land held together or connected land. So, that is how this, and according to this American Geological Institute, okay, they are saying Geological Society of America, it is it has all the qualifications of a continent, it should be declared as a continent, and if it is recognized, Zealandia would be the world's 8th and the smallest continent, because 94% is below water. So, it will be the 8th and the smallest one, and climate is generally mild temperate climate here, mild and temperate climate, and it has glaciers, and the largest the Tasman glacier, everything is there, mountains are there, glaciers are there. So, it is it satisfies the requirement of a a continent. That is what scientists are saying, but of course, I do not think it can be declared just like that, because there is no official body to do that, unless otherwise it is taken up by UN or something. So, right now the chance of it getting declared is quite minimal, right. So, that is about it. Now, but be aware, because this was still in news recently also, it was talked about for the last 3-4 years. Now, once again it was kicked up by somebody, so it was there in news. Okay. Now, now let me move into a bit more, what you call science related topics. A national digital health blueprint. Okay, national digital. In July 2019, the Union Ministry, the Health and Family Welfare, released a national digital health blueprint. The Union Ministry of Health and Family Welfare, it came up in the public domain, it is published. So, according to them, this national digital health blueprint is a citizen centric quality of care, better access, universal health coverage, everything. That is what we are seeing, and they are also trying to use the digital technology in the healthcare. The idea is to use or leverage digital technology in healthcare, and there is a national digital health mission. A national digital health mission is recommended to be established, or this blueprint talked about a national digital health mission to be established. National digital health mission to be established as a purely government organization, as a purely government organization with complete functional autonomy, similar to UIAD, Unique Identification Authority of India, UIDI, similar to UIDAI, or and the Goods and Service Network, GSTN, like that. Okay. So, we are talking about a national digital health mission. It is to be a new entity to be established, and the objective of this blueprint is to are aligned with the vision national health policy. The objectives of this blueprint is aligned with the national health policy or national health policy 2017. It is aligned with the national health policy 2017 and the sustainable development goals to be achieved by 2030. And the one of the this national digital health mission will be established in managing the core digital health data and infrastructure. Okay. So, it has to establish and manage the core digital health data, and the infrastructure required. Okay. It has to manage, and also it is to cover right from wellness to disease management. It will create a system of personal health records based on international standards. It will create a personal health records based on international standards. And easily accessible to the citizens. I mean, we have to create a personal health record based on international standards, easily accessible to citizens and to the service providers, of course, with the citizen consent only, and the best principles of cooperative federalism should be there. It also aims at following the best principles of cooperative federalism. So, all these things are these days in a fashionable terms. Quite unfortunately, nothing much is done, but we always talk cooperative federalism. And also it will bring in efficiency and effectiveness of governance at all levels, and this and that. Okay, all big things. So, this is the idea of the national digital health mission. A new entity is to be created according to this blueprint, similar to the unique identification development authority of India and the goods and service network and all GST and etc. etc. We are supposed to create one so that a global standards can be achieved. So there was a global digital health partnership summit in India. Okay, that is how it has come. Global digital health partnership summit. Okay, Global Digital Health Partnership Summit that is held in February 2019 in New Delhi. Global Digital Health Partnership Summit was held in February 2019 in New Delhi, and it was hosted by the Ministry of Health and Family Welfare and WHO and the Global Digital Health Partnership. Okay, so there is a Global Digital Health Partnership and summit was held. So what is the partnership? So Global Digital Health Partnership (GDHP) is an international collaboration of governments. So what is this Global Digital Health Partnership? It is an international collaboration of governments government agencies and multinational organizations, government agencies and multinational organizations dedicated to improving the health and well-being of the citizens, dedicated to improving the health and well-being of the citizens through the best use of evidence-based digital technologies, through the best use of evidence-based digital technologies. So, the best use of evidence-based digital technology. So, please remember Global Digital Health Partnership GDHP is an international collaboration of governments, government agencies, multinational organizations dedicated to improving the health and well-being of their citizens through the best use of evidence-based digital technologies. It is established in February 2018. Please remember, it was established in February 2018, and to provide an opportunity for transformational engagement between its participants, Australia was the first host country for the inaugural summit in 2018. Australia inaugural summit in 2018, and World Health Organization is also party to this. So, we have done. So, that is how this the Global Digital Health Partnership, and also we are talking about a National Digital Health Blueprint and also a National Digital Health Mission similar to Unique Identification Authority, Identification of Authority India Limited. Okay. So, this is been planned right now. So, that is about this particular global digital partnership, etc. Now, coming to another term which was in very much in news is the diclofenac. Diclofenac. Please remember, these are this has been recently or rather in news, or it is continuously in news because of the consumption of this by the vultures, especially the gyps species of vultures. It has just come down to 20,000, only 12,000 long-billed vultures in India, 12,000, then 6,000 white-rumped vultures, and maybe around 1,000 slender-billed vultures. So, the total vulture population have come down to less than 20,000, that is what it is said by in fact IUCN has declared all these three as critically endangered. Critically endangered species. Earlier it was thought that this is declining because of poaching, epidemics, habitat destruction, etc. That was the general explanation given. It was thought that it is getting killed because of poaching, epidemics, etc., habitat destruction, etc. But when an international study, an international team, dozens of scientists conducted a study, especially in India and Pakistan, under the direction of this Peregrine Fund. Especially in Pakistan, Peregrine Fund, and especially in Pakistan, it has found that the reason is not the habitat destruction or anything, it is the presence of diclofenac, a non-steroidal anti-inflammatory drug. Diclofenac, a non-steroidal anti-inflammatory drug administered to cattle. Population, and vultures which are feeding on the carcasses of these animals, the dead bodies of these animals, the cattle. It has found that these vultures are affected by this diclofenac, and it is affecting their there's a renal failure. The renal failure in vultures, and it is causing death. So, otherwise this diclofenac is a fast acting effective painkiller, and it also soothes, reduces the fever in cattle. It can be used in human beings also, but it soothes the fever, and it is cheap, and otherwise it is a very effective painkiller for cattle. But in India, since it is a India, we majority of the people, especially the Hindu community, since we do not eat beef, the cattle is allowed to die, and this carcass, its dead body is being fed by the vultures in India, and vultures are most abundantly found in Indian region, and they feed on these dead bodies or dead cattle, and that is why India has highest species diversity of vultures also, highest species diversity of vultures, and 9 species are found in India. 9 species in India, but today most of them are in the danger of extinction, and it is because of this diclofenac. I already told you, these vultures do not have a particular enzyme to break down this diclofenac. The problem is vultures do not have an enzyme to break down this diclofenac. And as I said, it is an anti-inflammatory drug administered livestock, and it can lead to it actually a direct inhibition of uric acid secretion. Problem in vulture is it inhibits, it prevents uric acid secretion. uric acid secretion in vultures are prevented, and this lead to the renal failure. Okay, that is why it is failure, and otherwise, that is the reason why. And because of this, white rumped vultures, which I said, it has fell by 99.7%. Hardly anything is left now. And similarly, the other vultures also, all of them have dramatically, reduced, and less than 20,000 population in India right now because of this. And this drug, this diclofenac, was banned in India in the veterinary use. It has been banned for veterinary use in 2006 itself. In India, it has been banned in 2006, and a replacement drug was introduced called meloxicam. A replacement drug was introduced called the meloxicam, and it affects cattle the same way. It can be used in cattle the same way, but it is harmless to vultures. And but the problem right now, even now, the problem is this, this diclofenac. This diclofenac, it is used for human use. It is still there in the human use. And this has been smuggled or black marketed into the animal, into the veterinary use also. The problem in India is, despite it has been banned, it has been it is smuggled or black marketed into the veterinary usage, and that is why still the problem, the vulture population is still in trouble. And the biggest consequence, what is the depopulation of vultures? The consequence of depopulation of vultures. Consequence of depopulation of vultures. See, we vultures are not there, what will happen? And it played a very important role in the public sanitation in India. So, it was very useful, and it played a very powerful, it is a powerful tool in public sanitation. And its disappearance has resulted in the explosion of rats and wild dogs. Explosion of rats and wild dogs have multiplied, and these are capable of spreading diseases also. And this has been, it is also contaminating the dead cattle which is lying in the field. It is contaminating the drinking water, contaminating drinking water. And in the process, since it has been eaten by mammals now, it carries diseases of rotting, rotting cattle or dead bodies, the carcasses. It is spreading rabies, anthrax, plague, etc. It can, mammals are capable of spreading rabies, anthrax, plague, etc., and which will be further problematic. So, the vultures, most of them are critically endangered, I already said, and then some of them are in the endangered category. 9 species are there. Now, we are developing even vulture safety zones. Okay, India has decided, or India has already developed some vulture safety zones to create awareness and to activities surrounding 150-kilometer radius of the vulture colonies, the main ones, to prevent the farmers from giving this diclofenac to the cattle. And one such big vulture safety zone is created, covering the Jim Corbett National Park, Dudhwa National Park, National Park, and Kartamia Ghat Forest Reserve in UP. Kartamia Ghat Forest reserves in UP, adjoining the Indo-Nepal border. No, Nepal has already set up a vulture safety zone on the Indian border. So, and we have a vulture safety zone surrounding 150 kilometers surrounding Jim Corbett, Dudhwa and the Kartamia Ghat, forest reserve in the India-Nepal border, so that we can prevent or rather we can protect these vultures from the diclofenac. I mean, we have banned it in 2006 itself, but still it is being used. That is why the problems are there. Let us hope we will be able to educate the people and save this vulture population. Okay, diclofenac is the culprit. Okay, now coming to in the corona time, we are hearing a lot about the vaccines, corona vaccines, and different types of vaccines are in news. I mean, according to WHO, at least 100 different vaccine candidates are in the race, but there are 4 main types of vaccine, and in all the 4 trial or other experiments are going on, so that we can have a corona vaccine. The first type we can say the live attenuated vaccines. Live attenuated vaccines. Here we are using a weakened or attenuated form of germ that cause the disease. We are using a weakened or attenuated form of the germ itself. Form of the germ itself is which causes the disease is used, and since they are using same and the natural, okay, these vaccines are so similar to the natural infection that help prevent, they create a strong and long lasting immune response. So, this can result, since we are giving a small or weakened in a germ itself, it can create a long lasting immune response. 1 or 2 doses of most live vaccines can give you a lifetime protection. Okay, 1 or 2 doses, 1 or 2 dose can give a lifetime protection. Lifetime protection against the germs and diseases, measles, mumps, rubella. Then even chickenpox, then influenza, rotavirus. Then rotavirus, yellow fever. In all these cases, we have live attenuated vaccines. And in corona also, across the world, according to WHO, 7 projects are going on. 7 projects are developing vaccine where the virus itself is used, which is in a weakened or inactivated form, where the virus in a weakened or in an inactivated form it is used. Okay. So, what we can say is, in our one type is live and attenuated vaccine, where the virus itself is used. Then the second one, we can call it as the the second type of vaccine which is in development. It is the inactivated vaccines, the killed version of the germ that caused the disease. Inactivated vaccine, the killed version of the germ. Killed version of the germ that causes the disease. So, the inactivated vaccines don't provide immunity that is as strong as the live vaccine. So, it provides less immunity as compared to the live one. Okay. Less immunity as compared to the live vaccine. So, we may require several doses, booster shots may be required. So, for getting immunity, like best example is polio, is an inactivated, hepatitis A, rabies. Rabies are examples of inactivated vaccines. So, in our corona also inactive vaccine trial is going on, or some many are trying to develop this, and so so that it can produce coronavirus proteins in the body. The idea is ultimately to produce coronavirus proteins in the body. So, since these viruses are weakened, they cannot cause any disease, and they are not only weakened, they are killed. Okay, and the method is used in case of even even the measles. This same method is used, and even Ebola vaccination. This is used. Okay, so the chemicals which is created. Okay, so that is how this is being done. The killed ones we are using it, and the proteins will be the inactivated ones will be created, and at least 25 different groups are trying to develop viral vector vaccines against the novel coronavirus. 25 different vaccines are under development in this model. Okay. Then a third model is a subunit or a recombinant or a conjugate vaccine, we can say a subunit or a recombinant or something, a protein, a sugar, a piece of a germ. It is not a subunit of a germ, recombinant or a piece of a germ. A piece of a germ is used. That means like protein, sugar, okay, or even a capsid or a capsid. Capsid means a casing around the germ. Capsid is the casing around the germ. So, here again these vaccines are only specific piece of germ. They give very strong immune response that targets that's targeted to key parts of the germ. Okay, so they can also be used almost everyone who needs them. Okay, including people with weakened immune system, etc. So here again hepatitis B, then in some of the influenza injections. Okay, so then many parts this is being used, or other there is a pneumococcal medicines, hepatitis B, influenza injections, also in the pneumococcal and the meningococcal. Vaccines, even HPV medicines. So, we are using the subunits or recombinant vaccines are used, subunits are used, subunits are used. And here in in corona, the scientists are trying to nucleic acid vaccines. The viruses nucleic acid is used. So, at least 20 different teams are aiming at least 20 different teams are aiming to create a vaccine through the nucleic acid of the or in the form of from the DNA or RNA. Okay, that is what they are trying to use it. Then finally, a fourth type of vaccine is the toxoid vaccines. Toxin. The toxoid vaccines, or it use the toxin, the harmful product, the protein that made by the germ that causes the disease. So, vaccines use the harmful, here they will use the toxin which is produced by the germ, the toxin which is produced by the germ or by the virus is used to treat the disease. So, they create immunity to the parts of the germ that cause the disease instead of the germ itself. Okay. So, it will create immunity to, through the vaccine, it will create immunity to these proteins or toxins which cause or other which is produced by the by the virus. So, this means that immune response is targeted to the toxin instead of the whole germ. The immune response is targeted to the toxin and not the germ itself. See, in diphtheria, tetanus are some of the examples of toxoid vaccines. Okay, diphtheria, and tetanus are some of the examples of toxoid vaccines. So, these are can also be done with the protein based vaccines. At least 28 teams are trying protein based corona vaccines for COVID-19. 28 protein based vaccines are under development. In this method, the coronavirus protein directly injected into the body. According to the Nature magazine, fragments of protein or protein shells that mimic the coronavirus outer coat can be used. The first protein based vaccine was developed for hepatitis B using this method anyway. So, this is the this is how the 4 different vaccines are under development. Let us hope some of them will be successful properly and it will be available throughout the world at a cheaper rate, and so that we can control, and then this is how we can bring in or reach the herd immunity ultimately. So, ultimately what is required is herd immunity, and we should be able to we should be immune from the disease, and vaccination is a must. So, that is all for today. I will be stopping here, and the next week we will be continuing with more topics, and we will be covering. Please study, please revise whatever topics we have covered, it is important, and we are also trying to pick up what can be asked in the exam. Please use it. Okay. So, that is all. Thank you. Bye bye.